Hello and welcome to this Science mini-masterclass video. This is part 7 of my calculations in chemistry series and in this video we'll be focusing on molar calculations. Please note this is for separate science aka triple science students only. As with all of my videos, I'll be helping you to secure knowledge of the facts and how to apply these effectively to exam questions. Plenty of hints, tips and common errors to watch out for along the way. Let's get cracking. Okay then, securing the knowledge of gas calculations. To begin with then, just a quick recap of moles. Remember, a mole is a word that represents a number. In this case, it's 6.02 times 10 to the power of 23 atoms, molecules, ions, whatever the substance may be. And this is called Avogadro's constant. And if we were to need to use that as part of an exam question, we'd be given that in the exam. Now, a mole of a gas, any gas, occupies a constant volume, a volume of 24 decimeters cubed or 24,000 centimeters cubed at room temperature and pressure. And room temperature is generally regarded to be 20 degrees centigrade and 1 atmosphere of pressure is for room pressure. So if we just look at 3 examples here, helium consisting of singular atoms. If we had 1 mole of helium, it would occupy 24 decimeters cubed. If I had a mole of oxygen molecules, again, they would occupy 24 decimeters cubed. And the same could be said for a mole of carbon dioxide molecules. Again, all occupying the same volume for 1 mole of a gas. Now, when we come to look at these exam questions next, I'll be using my 2 golden equation triangles of quantitative chemistry. If you're not familiar with these already, please check out some of my other videos such as concentration calculations, moles and advanced molar calculations. And again, if you don't know these off by heart at this stage, well worth writing them out on a coloured bit of paper, sticking them up on your bedroom walls. You see them twice a day, every day. You'll remember them by the time you come to sit your exams, because after all, there is no chemistry formula sheet. We have to learn these for our exams. So first question I'm going to look at, I'm going to do this one. Again, I'm going to apply the bug technique to begin with, and I've been asked to calculate the volume of carbon dioxide, CO2, produced when 3.57 grams of sodium hydrogen carbonate, a molecular formula given there for us, reacts with excess hydrochloric acid, and it's at room temperature and pressure. ATM stands for atmosphere. I've been given the relative masses, just the one, so clearly I only need one of them, for the sodium hydrogen carbonate. Just before I go any further, if you're wondering why they told us that it's excess hydrochloric acid, well, clearly the limiting reactant must be the sodium hydrogen carbonate if HCl is in excess. So it's the quantity of this reactant that's limiting or determining how much carbon dioxide I produce. Step 1. I'm going to work out the moles of sodium hydrogen carbonate using the actual mass and the relative mass. That's using my massive arm or massive Mr. Mole triangle equation there to get my moles, and it's 0.0425. Little examiner's tip coming up. Do not round as you go. Yes, this question has not asked for a certain number of significant figures. Nevertheless, if you start rounding, let's say to 1 significant figure, then that is going to impact on all of your subsequent calculations, and it will give you a different answer to the one that's acceptable on the mark scheme. Okay, so do not round as you go. Next step, the molar ratio. Now that's popped up in pink above the balance symbol equation. Now, seeing as there is no number in front of my sodium hydrogen carbonate and in front of my CO2, my carbon dioxide, I can assume there is 1 mole of each. I'm not bothered about the rest because those are not involved in the question. So if it's a 1-to-1 molar ratio, then I have the same number of moles for my carbon dioxide as my sodium hydrogen carbonate. So 0.0425 moles of carbon dioxide as well. Next step is to multiply the moles of carbon dioxide by the molar gas volume, 24 decimeters cubed. Final answer, 1.02 decimeters cubed. I get 1 mark for my moles of sodium hydrogen carbonate, 1 mark for using the molar ratio to determine the moles of carbon dioxide, and then 1 mark for my final answer. Right, one for you to have a go at then. This is worth 3 marks again, so you should be aiming to spend no more than 3 minutes on this question. Pause the video and I'll review in a moment. Right then, to begin with, you should have calculated your moles of Fe iron by using the actual mass from the question divided by the relative mass of iron. Next step, molar ratio, 2:3 ratio based on the balanced symbol equation. Therefore, we will need to multiply the number of moles of iron by 1.5, okay, because we multiplied 2 by 1.5 to get 3. We don't have 2 moles, we have 0.25 moles, so we're going to multiply 0.25 by 1.5 to give us 0.375 moles of Cl2. 2 marks so far. Final step, multiply the number of moles by the molar gas volume to give you 9 decimeters cubed. Right, last one. This is a slightly more challenging question. Okay, it's still worth 3 marks, but it's towards the end of the paper. Okay, if you're an EdXL student, we're talking probably question 8C rather than 8.3 in your exam, but nevertheless, still towards the end of the paper. So give yourself 4 minutes on this one as opposed to 3. Little hint, you're going to need to use the other golden triangle equation for this one. Pause the video and I'll review the answer in a moment. Okie dokie. Step 1. As before, we get our moles of our limiting reactant. In this case, it's the hydrochloric acid. And this time, to get our moles, we had to do concentration times volume. It's the MCV triangle equation. However, oh dear, we were given the volume in centimeters cubed and the concentration in moles per decimeter cubed. So you should have spotted the need for a unit conversion. And remember, one of my tips previously is include the units when you write out your, when you substitute your values, show the units as well, because you're more likely to spot a unit conversion. So divided by 1,000 to give you 0.05 decimeters cubed, multiplied by the concentration gives you your moles. Next step, it's a 2:1 molar ratio. So to get our moles of carbon dioxide, you could have either divided your moles of HCl by 2, or you might have thought, oh, I'm going to multiply it by 0.5. Same thing, gives you 0.03375 moles. And the final step, as with the previous examples, is to multiply by the molar gas volume, which was given in the question, to give you 0.81 moles. Job's a good one. That's a wrap. Part 7 of calculations in chemistry complete. Molar gas calculations ticked off the list. If you found that useful, please hit the like button. And for more science mini masterclasses, please subscribe to my channel. See you in the next one.